Welcome dear learners. Today we will discuss the properties of the steam. Now in this lesson we will see how water is get converted into the steam of various the processes. So in the picture if you see here the steam engine is there. So this one is nothing but the graph for temperature versus entropy, and this picture is nothing but conversion of water into the steam. So this is nothing but actually a boiler. Now, so properties of the steam. First of all we will discuss what is the steam. So steam is a vapor or gaseous phase of water very initially. Note that. So steam is the vapor or gaseous phase of water. Steam itself is a water but in a vapor phase. It is produced by heating of water and carries large quantity of heat within itself, because when we are heating the water, so amount of energy or amount of heat that will be carried by the steam. Hence, it could be used as a working substance for heat engines and steam turbines. So in case of petrol engine we require the petrol. So in the petrol engine, petrol itself as a working substance. So in the case of heat engine and steam turbines, so working substance is the steam. But it does not obey the ideal gas laws because that is not in a dry form or that is not perfectly dry. But if we heat the steam beyond the superheated or in the superheated region, then the superheated steam behaves like an ideal gas. So if you see here, wet steam do not obey the gas laws of Boyle's and Charles laws, as it is not in a pure form. So see here, this is the steam generator or the turbine, steam turbine, which is used for conversion of the steam into the electricity by conversion of that particular pressure energy into the mechanical energy, and again this mechanical energy into the electrical energy by connection of the steam turbine into the generator. So this is the steam engine which is further is used for to drive the railway engine. So and this one is the boiler which is used conversion of water into the steam. Now next is nothing but how steam will get formed from the water. That is the important. So in this case we will going to discuss how the constant pressure formation of steam takes place from the water. So initially consider 1 kg of water. So here consider 1 kg of water at 0 degree Celsius contained in the piston cylinder arrangement. The piston and weights maintain the constant pressure in the cylinder. So here weight are put on the top of the piston, so that constant pressure is maintained. If you heat the water contained in the cylinder, now if you are going to heat the water, then there will be the slight increase in the pressure as well as the slight increase in the volume takes place, and the water get converted into the steam. Initially the volume of water will increase slightly with increase in the temperature when we are heating this water. So if you observe here, so while observing here, so slightly volume of the water gets increased. It will cause the piston to move slightly upward and hence work is obtained. This increase in volume of water generally neglected for all types. On further heating, temperature reaches to the boiling point. The boiling point of water at atmospheric pressure is 100 degrees Celsius, but it increases with increase in the pressure. As the pressure get increases, the boiling point is also increases. When the boiling point is reached, the temperature remains constant. And the water evaporates, thus pushing the piston against the constant pressure. So specific volume of the steam increases. So here if you note that the volume of the steam gets increases, and in the third stage, this one is the combination of water plus liquid. So here this is the stage. Now at this stage steam will have some particles of water in a suspension. So here some water is there in a steam, and we call that steam is a wet steam. We call that steam as a waste steam, and this process will continue till whole water is get converted into the steam. Okay, up to this point. On further heating, the water particles in suspension will be converted into the steam. So now if you see here, some water particles is also present in the steam. So on further heating, this water particle is totally get converted into the steam, and if water particle is not present in the steam, we call it as a dry saturated steam. So entire steam is in the dry form, and we call it as a dry saturated steam. Practically, dry steam also behaves like a perfect gas. Again, on further heating, the temperature of steam start rising. The steam in such a state is termed as a superheated steam. Today we will discuss this temperature versus the heat added graph. So in this case, so here 0 degree Celsius of solid is present and 0 degree Celsius of liquid is present. Fine. So A is nothing but the sensible heat taken by ice. So let's suppose very initially the minus 10 degrees Celsius of ice is present here, and up to 0 degrees Celsius the heat taken by the ice is nothing but the sensible heat. So this is nothing but the sensible heat, and so sensible heat is nothing but the amount of heat required to rise the temperature. So here minus 10 degrees Celsius to the 0 degrees Celsius. So the temperature difference delta T is equal to 10 degrees Celsius. So this amount of heat is nothing but the sensible heat. So here B is the liquid plus solid. So in this case C, so if you see here B is the latent heat of fusion. So latent heat of fusion is nothing but the 0 degrees Celsius of solid is totally converted it into the 0 degrees Celsius of water at constant temperature, pressure. So these curve or these lines belongs to the constant pressure line, and here the 0 degrees Celsius of the solid get converted into the 0 degrees Celsius of water, and that we call it as a latent heat of fusion. Now on further heating, so here if you see here the 0 degrees Celsius of water is there. Now this 0 degrees Celsius of water is get converted into the 100 degrees Celsius of water. So 0 degrees Celsius of the 0 degrees Celsius of water is get converted into the 100 degrees Celsius of water at this position. Now this we call it as that particular specific enthalpy of water. So C is nothing but sensible heat taken by water. So amount of heat required to conversion of 0 degrees Celsius of water into the 100 degrees Celsius of water is nothing but sensible heat of water. Then here from 100 degrees Celsius of water into the 100 degrees Celsius of steam, we call it as a latent heat of evaporation, which means 100 degrees Celsius of water is get converted into the 100 degrees Celsius of steam at constant pressure temperature. We call it as a latent heat of evaporation. Now here at point D, if you see here at point D is nothing but the saturated liquid, which means that so there is no solid particles are present, that is completely in the liquid form, and when on further heating that particular liquid starts converted into the steam. Now on further heating, so steam is get converted into the vapor state, and at this point E is nothing but the complete vapor. Now there is no any water particles are present, but in between D and E some liquid as well as some vapors are present. So this actually D is nothing but the sensible heat taken by the latent heat of evaporation, and again further heating. So this is the sensible heat taken by the steam to get converted into the superheated steam. Fine. So if you see here, the HW is the specific enthalpy of water. So this is the specific enthalpy of water. HF, so a specific enthalpy of saturated water. Up to this we call it as a HF. HF is the latent heat of evaporation. So this is the latent heat of evaporation. This D2 is area. HFG, sorry, this is the HFG actually. This is the HFG. So if we can see here, so this is the HFG. Okay. Then H is the specific enthalpy of dry saturated steam. So this total is nothing but, so if you see here, so this is the HFG from this to this, and this is total HG. So this is the HG. Fine. So if you see here, in this case, when in any solid phase, on further heating, addition of heat, the solid gets converted into the liquid. On again further heating, addition of heat, so it will be get converted into the gaseous phase. And if anything, if water is in the gaseous phase, then when we are removing the heat, then it will be get converted into the liquid phase. Again we are removing the heat, will get the solid phase. So this negative heat is nothing but your refrigerator. Fine. Now steam exit in the following state. So there are different types of the or condition of the steam. So first steam is the wet steam. When the steam contains moisture or particles of water in a suspension, and it is said to be wet steam. So if it is the mixture of dry steam plus some water particles, so we call it as a wet steam. Okay, it means the steam is not in a completely pure phase. Fine. Second, dry steam. So all water is completely converted into the dry saturated steam. That means total water is get converted into the steam. We call it as a dry steam. So we will given as the HG. Then superheated steam, when the dry steam is further heated at a constant pressure, thus raising its temperature, it is said to be superheated steam. And since pressure is constant, therefore the volume of the superheated steam increases. It may be noted that the volume of 1 kg of superheated steam is considerably greater than the volume of 1 kg of dry saturated steam at same pressure. Now if you see in this case, so this is the volume of the dry saturated steam, and this is the volume of the superheated steam. Now if we see in this case, the volume is too much more than the dry saturated steam. Okay, now we will discuss the enthalpy of the steam. So there are different types of the enthalpies of the steam. So first is the enthalpy of the liquid or sensible heat HF. It is the amount of heat required to raise the temperature of 1 kg of water from 0 degree Celsius to its saturation temperature at constant pressure. We call it as a HF. Fine. Now, so HF is equal to CPW into T saturated minus 0 degree Celsius in kilojoule per kg. So CPW of water can be taken as 4.187 kilojoule per kg Kelvin. So now if you see in the graph, so this is your solid plus liquid, and this is your on further heating. So we consider this is as TS, T saturation, and this is your 0 degree Celsius of water. So this total on the heat is nothing but the HF. This is nothing but the HF. Now enthalpy of evaporation or latent heat. It is the amount of heat required to change the phase of 1 kg of water from saturated liquid state to the saturated vapor state at constant saturation temperature and pressure. Now, so if you see here, so this is the graph we already discussed. So this is 0 degree Celsius of water is present, then on further heating this is your sensible heat of, and this is the latent heat. So this saturation temperature of liquid, so this is your H of G actually, this is your H of G, okay, this is your H of G, fine. And enthalpy of dry saturated steam, so it is the total amount of heat required to generate 1 kg of saturated steam from water at 0 degree Celsius. So this is denoted as a Hg. So Hg is equal to total Hf plus Hfg is nothing but the enthalpy of the dry saturated steam. Dryness fraction of the steam. So what is the dryness fraction? So it is the measure quality of a wet steam. So in a steam, in a region of that particular liquid plus vapor, so some amount of water also present in the steam, and it is the ratio of mass of dry saturated steam to the total mass of wet steam. So here X, we denote it as a X, that is the dryness fraction, mass of the steam divided by total content, that is the weight of steam plus weight of water vapor. So it means how much amount of steam is present that in that particular mixture. Enthalpy of a wet steam, how we can calculate the enthalpy of a steam? Let's suppose, so here this is your diagram and this is your liquid plus vapor region. So here I want to calculate the enthalpy of the wet steam. So how I can calculate the enthalpy of a wet steam? So which can be calculated by H is equal to, so total enthalpy at here. So it is the total amount of heat required to generate 1 kg of wet steam having dryness fraction X from water at 0 degree Celsius. It is the amount of, or it is the sum of sensible heat plus latent heat taken by part X, that is the dry part X of the wet steam. So this is total your H of G. So let's suppose this is your H of G. So H of G, and this is your dryness fraction. Let's suppose X is equal to 0.6 and some value of HF is given. So this total H enthalpy content at here should be equal to this HF plus HFG into this X, that is a 0.6, that is your 0.6. Clear? Enthalpy of superheated steam, how to find out the H sup? So it is the total amount of heat required to generate 1 kg of superheated steam at required superheat temperature from water at 0 degree Celsius. Superheated steam behaves like an ideal gas and obeys the gas law. So H superheated is equal to HF plus HFG, that is the total heat contained up to the saturated gas plus the heat, that is CPS into T sup, that is the superheated temperature minus saturated temperature of that particular steam, which is equal to the Hg plus CPS into T sup minus T sat. So this CPS is equal to 2.1 kilojoule per kg Kelvin, that is the specific heat of the superheated steam. So what is the heat of superheat? The amount of heat required to get superheated steam from dry saturated steam, we call it as a heat of superheat, and which is equal to CPS into T sup minus T sat, that is that in the previous formula, that fraction. Degree of superheat, it is the temperature difference between the superheated steam and dry saturated steam. We call it as a degree of superheat. Specific volume of the steam, it is the volume occupied by the steam per kg of its mass. Specific volume of a dry steam Vg, its value can be obtained directly from the steam table, and the specific volume of a wet steam, that V is equal to X into Vg. Specific volume of the superheated steam calculation, the formula is V superheated, that is the specific volume of the superheated steam, is equal to Vg into T sup divided by T sat. So this is what the how we can find out the internal energy of the steam. So this is the enthalpy U plus PV. So U can be calculated by having the H minus PV. So P is the pressure of the steam, V is the specific volume of the steam at a given pressure temperature. So this is the U for wet steam, that is the H minus P into V. Similarly, we can find out for the dry saturated steam and superheated steam. In this case, so this is the PV diagram and this one is the TS diagram. So this is your liquidus line, that is the saturated liquid line. So here this is a critical point. After further heating, this liquid is get converted into the vapor form, and this is the superheated vapor or in the vapor state, and in between these two, so liquid plus the vapor is there. Okay. Now same in the, that is given in the TS diagram. So saturated liquid line, this is the triple point of water and all. Fine. So in the steam table, this one is actually given. So what is the, how we can read the steam table? So if the values in the numerical is given in the absolute pressure, that is in given bar, then at that particular pressure what will be the saturation temperature in degree Celsius. So specific volume is given in meter cube per kg, that is the V F for fluid, that is the water, and G for the steam, that is for the gas. Specific enthalpy, that is the H, HF, HFG and HG at the particular pressure temperature is given, and specific entropy in kilojoule per kg, that is the SF, SFG and SG is given. So if you see, we will see in the, so see here, so this one is the one format for the steam table. So here the saturated water and the steam table is given. Saturated water on the basis of temperature, on the basis of the pressure is given. So these are the again specific volume of the superheated steam, specific entropy of the superheated steam, and the specific entropy of the superheated steam. So these are the different types of the steam tables are given. Now if you see, so saturated water and steam table is given. Now if you want to find out the, let's suppose at saturated at 1 degree Celsius, what will be its HF. So at 1 degree Celsius I will definitely read the, so at 1 degree Celsius I will definitely read the, what will be its HF. So this one is the at 1 degree Celsius 4.2, that is the HF. HFG is the 2499.2 and HG is the addition of these two, that is the HG 4.2 plus 2499.2, that is the 2.0903.4. Similarly, if you see now, okay, wait, I will just delete it. And suppose now I want to find out the values on pressure basis. So again in the table 2, if you see here, the table 2 is given, and in the table 2 the values are given on the basis of absolute pressure in the bar. So if I want to find out the values at 5 pressure, so here if you want to find that 5 pressure, so this is the 5 bar pressure, and based on the 5 bar pressure, so we need to find out the values of, so this one, the, oh I'm sorry, so this is the value of the HF. So this is the HF value, this is the HFG value, and this is the HG value. So in this way we can easily find out the different values from the given table. Fine. So we'll see one numerical, and then we will stop here on the problem. So calculate the total heat of 6 kg. So amount of 6 kg steam is required, and at absolute pressure of 8 bar. So at 8 bar we have to find out the values, and dryness fraction of the steam is given. It means that, so here the steam is the wet steam. So which type of the steam is the wet steam? Also calculate the heat in kilojoule required to convert the steam into dry and saturated steam. So here that wet steam is get converted into the saturated steam. So how much amount of the heat is required to convert the wet steam into the saturated steam, that is the dry and saturated steam. Okay. So from steam table we will find out the pressure, different values at pressure is equal to 8 bar. So from the steam table we'll we'll directly go to the steam table at 8 bar. So at 8 bar, so now we can see here, so at 8 bar, so here at 8 bar, I'm sorry. So at 8 bar you find out, so values at 8 bar, so HF is equal to 720.9. this is the value of HF. You can see there HF is equal to 720.9, HFG is equal to 2046.5 and HG is equal to 2767.4. Now you can see from that particular table, so 720.9, so these are the values. So enthalpy of steam we already discussed, so we can calculate it by using specific HF plus X into HFG. So X is the dryness fraction is given, so by putting the value we will get the value of 2358.1 per kg. So we required at the 6 kg of the steam, so we will multiply it by the 6 kg into the specific enthalpy. So total volume is, total answer is the 14148.6. so now how much total amount of steam is required for the 6 kg, actually here 5 kg is given, so this is the 6 kg of dry saturated steam, which is equal to 6 into Hg. So Hg is nothing but the enthalpy of the dry saturated steam, and which is equal to 16604.4 kilojoule. So how to find out the net heat required to convert the wet into the steam? So wet steam into the dry and saturated steam, so conversion of this, how much amount of heat is required? So here we have to find out the total heat at wet steam minus here we again find out the value of the total heat at dry saturated steam. So difference between the total heat at dry saturated steam and the wet steam, the total heat contained in the wet steam is nothing but your total heat is required, we need to supply for conversion of wet steam into the dry saturated steam, and which is further is equal to 455.8 kilojoule amount of heat is required to convert this wet steam into the dry saturated steam. So thank you very much for this session. We will discuss more numerical based on these properties of the steam. Thank you.